So my project is restricted earth fault. I have been to India for last 1 month, and in past couple of weeks I had been working under the guidance of Deputy Engineer J.D. Koryard, who is working in the electrical government company. So I had been working with him, and at the present moment, the scenario is that in the protection system over the 50 MVA transformer, it is mandatory to place the highly sensitive protection system, which was not the same earlier, but in past couple of time, it's been mandatory for the 50 MVA transformer to have a highly sensitive protection system. So we had studied the same protection system, and we have made the same hardware simulation of the same system in my project. And the main advantages of this project is it restricts the zone of the protection. That means, let's take an example to understand this point. That if it is a 100-kilometer transmission line, it is very hard for us to detect the fault. But if we restrict the zone, if the zone becomes very small, it is very easy for us to find the fault. And so this is how. That's why we say it is restricted fault protection. So it is very highly sensitive. It senses the fault near to the earth. That means if let's take the differential protection. In the differential protection, the 20% of the winding is biased. That means if there is a fault in that 20% of area, it won't be able to detect by differential protection. But with the help of this system, we can even detect that 20%. If there is fault in that 20%, we can we would be able to find that fault. And as we know that near to the earth, the fault near to the earth is very hard to detect. So this system is so sensitive that it will even detect the fault near to the earth. So that's why it's highly sensitive, and it can detect it can sense the fault near to the earth. And the last point, which is one of the most important points, is highly stable in external fault. So if there is external fault, true fault, it won't affect at all to the internal protection system. It won't affect at all, and it won't harm the protection system, and it won't affect at all. So let's in the next video I will show the real simulation of the same thing, and we'll prove all these points, and we'll have a look at it. The points that I had covered in the last simulation, I will show all the points in this hardware simulation of the project. This is the circuit breaker. This is the real transformer, the primary and the secondary. And in the secondary of the transformer, we have made the tappings, which is 5%, 10%, 20, 30, and 100%. So the trappings are made at all these percentage in the secondary of the transformer. To select the phase of the transformer, we have placed the phase selector switch, and to select the tapping, we have placed the tapping selector switch. So with this, we can select the tapping of on the secondary of the transformer. The next is the internal fault. We can virtually generate the internal fault in the system, so that to generate the internal fault in these windings, we have placed virtual internal fault. This is the CT, and that is the relay that will sense the. This is the relay that will sense the fault. So now I will show all the components that are in this project. The first is the circuit breaker. The circuit breaker, we have used contactors. These are the contactors. We have used the contactor as the circuit breaker, and this is the main transformer with the tapping. and this is the current transformer. So I will show all these components, the phase selector switch and the timing selector switch at the back of the panel. So this is the main transformer with tapping on the secondary. This is the secondary, and you can see the tappings, which is 10%, 5%, 10%, 30%, and 100%. The next is the current transformer. And this is the phase selector and the tapping selector switch. And that is the relay. We have included the load, and we have included the flasher circuit, which just shows us the indication and the flashing so that anyone can be able to know the fault visually. So let's begin the project. First of all, I will run this project. So with this virtual fault generation, this is the phase. So at the moment, it's the third phase is selected, which is to this phase selector switch. You can see it is at the third phase, and the tapping is at 5%. I have selected. Let's take the second tapping, which is 10%. So at the moment it is at 10% of the tapping, and now we will generate the fault. This is the digital ammeter with which we will be able to see the fault current. So please do have a look at the fault current, and even at the moment I switch the internal fault, please do have a look at the internal fault current. So this is how the fault has generated, and you can see the flicker and even the visual effect, so that we will be able to see the fault. Now we will stop the fault, and now we will select with 20%. So now the 20% of the winding is selected, and now we'll in the last video I had shown the fault at 10%, but if the tapping is if the fault is very near to the earth, the fault current will be very small. So let's take the fault at 5% of the winding. And the 5% of the winding, the fault current would be very small. And in this project, I will show the fault current at 5%. So when I will generate the fault, you will be able to see the fault current over here. And this simulation will detect even that small amount of current. So now let's start. The protection is on at the moment, and now we will virtually create the fault. So this is the fault current, and the flag of the relay is set. You can see the flag. And at the moment, you will be able to detect that there is a fault generated in the system. In the real protection system, any of the technicians should go at the present slide and can see that there is a fault generated. Now, as the fault is detected, we will accept the fault, and now we will now we can find the fault. We can detect the fault, and this is how the whole protection system works. I will reset the system. And now the system is again back to its normal condition. So now we'll generate the fault at 20%. Even if you select the 20% of the winding, you will be able to see the fault current at 20%. So let's create the fault. Please do have a look at the fault current. So the fault current is 6.8 amperes, and the protection is, the flag is set. You can see the flag, and the protection is operated in the mode. So let's hit the fault and reset the whole system. And now we'll see the fault is 100%, which is at the end of the secondary, at the last winding of the transformer. So we will again start the protection. We'll generate maximum fault, and we'll see the current is 7.8 amperes. You can see the protection is operated and the fault current is overcome, and we will reset the flag. So reset the fault, reset the system, and again the system is normal back to its condition. So this is the real simulation of restricted earth force.